Hello, my name is Chase Amerson. I've done my presentation on the guar bean and fracking. The guar bean, basically the origins are unknown. It's been domesticated in India, Pakistan, and it's been cultivated there for many centuries. So we have given that pretty much their basic origin. 80% of the production comes from these two countries. The demand has pretty much been increasing for industrial use with hydraulic fracking, and there has also been some human uses that has been done for medical purposes too. Growing guar. This is pretty interesting. It's very drought tolerant, it's sun loving, but it is very susceptible to frost. It's grown principally in the northwestern areas of India, but it has also been found to grow pretty well in the high plains of Texas. So, furthermore, some optimal temperatures for the root of the plant to mature quickly in the proper manner has been found to be at 77 to 95 degrees Fahrenheit. It has also been shown to help farmers who grow multiple crops all year round. Guar has been shown to be a soil improving crop, so not a constant use for nitrogen use in the ground to keep fertilizing. You can use this to replenish the nutrients in the ground. Here's a picture on the bottom of the guar plant itself. Here also is the top is the guar bean itself, and then inside you can see the grain, and then you can see the endosperm in the hull, which is what the guar gum is used in the hydraulic fracking, which we'll talk about later. Hydraulic fracking, hydraulic fracturing, has also been known to fracking as many people in the public media and social media. It was first used in 1947. A man by the name George P. Mitchell has been known as the father of fracturing. In 2012, there was an estimate of 2.5 million jobs have been created worldwide by this little niche market, and more than 1.3 million of those have been created here in the United States. And during this recession that we're having, this is a great way to put people back to work. The guar bean and fracking. So pretty much the demand has grown as fracking has grown. And down here at the bottom, this is explains how it works. Well, what fracking does is they push water and chemicals down into the ground with pressure, and they go down far enough to where they find hard rock. Well, when they start pushing the pressure up, it will create cracks in the ground, fractures, and this will dislodge either natural gas or oil. And when the oil and natural gas escape, the guar gum, which is a thickening agent, is used to push the fluid sideways, so the actual goods, which would be the natural gas and the oil, can escape up to be captured. Fracking. Now we have some pros and cons to this. It's a cleaner alternative to coal and oil, different types of like shale oil and shale gas. It says here shale gas is now cheaper than coal. It also provides us with a greener future, and there's about 2,400 trillion cubic feet of recoverable natural gas in the United States. So no use to keep buying oil overseas or coal. Possibly dirty drinking water is a possibility on the con side, but I have a feeling that this shows that either county or state water treatment plants aren't doing their jobs correctly. There is a downside. The EPA hasn't pushed out regulations for methane, and seeing how this releases methane into the air, which is 20 times more potent than CO2. And this is a theory growing amongst many scientists that it can cause deep cracks in the earth. Here's some fun facts. Some of the basic chemicals used in fracking. The guar gum, which we've been talking about. Sodium chloride, which is known as salt. We have citric acid, which can be found in oranges, lemons, and limes. Isopropanol, which has been found in disinfectant wipes. And ethylene glycol, which is found in a lot of the thermal paste, which is used to cool, is the cooling agent found in many of your laptops, tablets, cell phones, pretty much any electronic object in this room. I also have found two interesting information sites. One is the US debt clock, so we can actually see how much money we're actually creating and how much money we're spending to gain energy in different countries. And then I have another one, which is a GIS map of Colorado, in which we can look and see of active permits, inactive permits, active wells. You can see streams and rivers based on the map itself. And then here are my sources, and that's it. Questions?